right, so now that we've defined what we mean by saying a number divides another number, we want to establish some tests for determining divisibility. Now, some of these tests hopefully are familiar to you, and some of them might be a little newer to you. So how do I decide if a whole number is divisible by 2? Well, I look at its units digit, and it's divisible by 2 if and only if its units digit is divisible by 2. Hopefully that's one you've seen before. This one too you've probably seen. How do I decide if a number is divisible by 5? We look at its last digit, the units digit, and it's divisible by 5 if and only if that units digit is 0 or 5. We test for divisibility by 10 by also looking at the units digit, and it's divisible by 10 if and only if that units digit is a 0. All right, this one might be new to you. A whole number is divisible by 4 if and only if the last two digits of the number represent a number divisible by 4. So now instead of looking at the last digit, we're going to look at the last two digits and test if those are divisible by 4. Our test for divisibility by 8 has us look at the last three digits of the number, and if those last three digits are divisible by 8, then our whole number is divisible by 8. All right, so let's try using the tests. Oops. So I have 876,164, and I'm going to test for divisibility by all the numbers. So is it divisible by 2? Yes, we're going to look at the last digit, so you should always give a reason. Yes, because 2 divides the last digit 4, right? 4 is divisible by 2. Is it divisible by 5? Well, again, our test is to look at the last digit. The last digit is 4. That's not a 0 or a 5, so no, because last digit is not 0 or 5. Is it divisible by 10? No, because my last digit is not 0. Is it divisible by 4? So divisibility by 4, now I'm going to look at the last two digits. So the last two digits are 64, and I want to know, does 64 divide is 64 divisible by 4? Well, yes, because 4 divides 64. You might need to have checked that. Oops, sorry. (64) divided by 4 is going to be 16. And what about 8? Is 64 divisible by 8? Nope, I need to look at 164. So here you might need to do some scratch work. 8 goes into 16 twice. I subtract and I'm left with 4. 8 goes into 4 0 times, and I have a remainder of 4. So the answer here is no, because this, right? 8 does not divide 164. All right, what about part B? I'm going to let you try that. Okay, so we have this little diagram of numbers divisible by powers of 2. So if your number is divisible by 8, then that means it's also divisible by 4. So it lies inside this bigger circle, right? And if your number is divisible by 4, then it's definitely divisible by 2. Okay. Let's add a couple more divisibility tests. So a number is divisible by 3 if and only if the sum of its digits is divisible by 3. So I'm going to add up its digits and check if that number is divisible by 3. We have a similar test for divisibility by 9. So a number is divisible by 9 if and only if the sum of its digits is divisible by 9. So let's try doing that. So is 1002 divisible by 3 or by 9? So I'm going to add up its digits. 1 plus 0 plus 0 plus 2. That gives me 3. Well, 3 does divide 3. So 1002 is divisible by 3. But 9 does not divide the sum of the digits, right? 9 does not divide 3. So 1002 is not divisible by 9. All right, what about 14,238? So again, I just want to add up the digits. So 1 plus 4 plus 2 plus 3 plus 8. I get 5, 7, 10, 18. Okay, well 3 does divide 18, right? 3 times 6 is 18. So 14,238 is divisible by 3. And 9 also divides 18. So I'm going to write this a little more simply. 9 divides 14,238. All right, so those are our tests for divisibility by 3 and 9. Let's look at a slightly more complicated example. So suppose we have an invoice for 72 calculators. We know the we don't know the first and last digits on the receipt, but the manager can read some digits in the middle. So we want to know what are the missing digits and what is the cost of each calculator. Okay, so we're going to represent our missing digits with an X and a Y. And let's just switch our dollars to cents. So we have X 679 Y cents. So what do we know about this total? Well, we know that 72 must divide this total because they purchased 72 calculators. So I can write 72 times 8 as 8 times 9. And so if 72 divides the total, then 8 divides the total and 9 must divide the total. Okay, so by my divisibility tests, I know that since 8 divides the total, the 3-digit number 79Y, those are the last 3 digits in that whole number, have to be divisible by 8. So I can use that to figure out what Y could be. And now you could just run through the possibilities for Y. So check if 790 is divisible by 8, 791, 792, all the way up to 799. And what you'll find is only 792 is divisible by 8. So Y has to be equal to 2. Okay, so now I can fill in that last digit. I also know that the number on my invoice is divisible by 9, so that means that 9 has to divide the sum of the digits. The sum of the digits now is X plus 6 plus 7 plus 9 plus 2, or X plus 24. So what could X be if X plus 24 has to be divisible by 9? Well, actually, you'll find that only 3 is the only number that will work. So if X is 0, I get 24, that's not divisible by 9. If X is 1, I get 25, not divisible by 9. If X is 2, we get 26, not divisible by 9, and so on. You should check all the way up to X equals 9. X is 9, I get 33, also not divisible by 9. Okay, so 3 is the only option that will work for X, so that must mean that X is 3. And now we know what the total invoice was. It was $367.92.